In the last video we've talked about and worked with linear functions, and in this video we're going to talk about quadratic functions. And specifically how we can, the first part is how we can graph quadratic functions using transformations. We've already talked about graphing quadratic equations, so if I asked you to graph, for example, the quadratic equation y equals 2x squared minus 3x minus 7. We did this previously, so we know since it is a quadratic, since it's degree 2, that when I make my graph that I will have a parabola. And so we would go through the process of finding the vertex, finding the intercepts, and any other points that we might need to go ahead and graph the given parabola. Here, instead of using this point finding method, we're going to talk about how we can graph quadratic functions using transformations instead. And just as a clarification, it is okay when we're dealing with quadratic equations. We know that if we have a parabola that opens up or a parabola that opens down, they do pass the vertical line test, so we are dealing with functions. So it is acceptable to, rather than using y, use f of x. Okay? So, what we're talking about here is simply a different method for graphing quadratic functions rather than a point finding method. And graphing using transformations is something that is very useful and very helpful, especially if you go on to take a trigonometry class. It's very nice to know how to, or to have some kind of a background in graphing using transformations. And so anytime you graph a function using transformations, you always have to start with some basic function. So if the function that you're asked to graph is quadratic, then you would start with the basic quadratic. Okay? What you see here is the graph of the basic quadratic function f of x equals x squared. And you can see I've highlighted a few points on this graph for you. I have a point at negative 2, 4, and you see algebraically if you substitute negative 2 in for x, negative 2 times negative 2, that corresponding output is 4. So some of the points on the basic, we have one point at negative 2, 4, we have another point at negative 1, 1, 0, 0, 1, 1, and 2, 4. And you can see if you do substitute negative 1 in for x, negative 1 times negative 1 is positive 1. 0 in for x, 0 times 0, we do get a y value of 0, etc. Okay, so to be able to successfully graph by transformations, you need to know or find some points on the basic that you will then transform, that you will then move. Okay, and if you're given an equation that's in this form, you can graph using transformations in this form: a times the quantity x minus h squared plus k. And there's more to it than what we're going to do here, but we're just kind of starting small. So if you're looking at this quadratic function, if the value of a is negative, you're going to take your basic and you're going to flip it over the x-axis. And when we say flip it over the x-axis, that's a proper way would be to say to rotate it. But what you do anytime you want to flip a graph over the x-axis is you take any point on the graph. If there's any point on the x-axis, that point stays fixed. And then what you would do is basically take this and just fold it over the x-axis. So if I take the graph that I see here and I flip it over the x-axis, then this point will be here, this point will be here, this point up at 2, 4 will now be at 2, negative 4, and this point will be here at negative 2, negative 4. Okay? I apologize for my poor graphing, but that is what the graph of f of x equals negative x squared would look like, okay? If you would just take this and flip it over the x-axis. If you're dealing with a function where you have inside with the x some number, then you will need to shift your graph either to the left or to the right. If you have x minus a number, you're actually going to be shifting your graph to the right. If you have x plus a number, you're going to move every point on the graph h places to the left. Okay? And then if your function has a constant value out here, that tells you that you would need to either shift up or shift up is if k is positive, or shift down if k is negative. And that would be however many k places you need to go, whatever that value is. Okay, so let's look at an example. So if I'm wanting to graph this function, and I should have erased these directions, not find the vertex and intercepts to graph, but instead graph using transformations. Anytime it says graph using transformations, what you're always going to do is start with the basic. So looking at this function, it's a degree 2, so it is a quadratic function, and so my basic is the basic quadratic, f of x equals x squared. Okay, and so if I want to start with the basic, I have to start with points that are on the basic. Okay, and when you're dealing with a basic quadratic, you need to get used to the points, using the points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Okay, so you would start by placing all of those points on the graph. So point at -2, +4, -1, 1, 0, 0, 1, 1, 2, 4. And so what we're trying to do is to graph this parabola by taking this parabola and shifting it. Okay? So if you have a negative out front here, you'll need to, so if a is negative, you're going to flip it over the x-axis. A is not negative, so in this example, there will be no flipping. Okay? Then, if there's a number inside here with the x, you're going to have to take your basic and shift it to the left or to the right. In this case, since we have +3, it's actually counterintuitive, we have to take our points and move them to the left 3 places. So if necessary, and it's only necessary if there's a number in here with the x, you would move the function to the left or to the right. And in this case, since we have a +3, we're going to move every point to the left 3. Okay? And then finally, if there is a number here, so if necessary means if there is a number here, you will move the function up or down. If it's plus a number, you'll move it up. If it's minus a number, you'll move it down. So in this case, since we have -2, we're going to move every point down 2 places. Okay? So I'm going to change my ink color, and I'm going to use blue, or whatever color I just got. I got blue. So I'm going to take every point here, I'm going to move every point to the left 3 and down 2. And once I have done that, the points that I see on my graph should be points that are on this and this parabola, and I can then just make my parabola through those points. So I have to move every point left 3. So I'm going to take this and go left 1, 2, 3, and down 1, 2. So that point, when I go left 1, 2, 3, and down 2, that point will move here. Okay? Take this point, move it left 3, 1, 2, 3, down 2, it is now here. Okay? Left 3, 1, 2, 3, down 2, this point is here. And I'm just crossing them off as I go so I keep them clear. So left 1, 2, 3, down 2, that is here. And left 1, 2, 3, down 2, that point is there. Okay, so this is the graph of this parabola. And I was able to find that just by shifting the points on the basic rather than doing what we were doing before. So in the last chapter, you know, what we are familiar with, we would have maybe seen y equals the quantity x plus 3 squared minus 2. And we discussed that if you wanted to graph by finding the vertex and the intercepts, the vertex would be at -3, -2. And let's check it. Is it? 1, 2, 3, 1, 2. It is. And then we would substitute 0 in for y to find the y, or I'm sorry, 0 in for x to find the y-intercept, and 0 in for y to find the x-intercepts. And so, you know, that was one method, and I'm giving you now just another. This is just another method that you can use for graphing when the function is given to you in this form. If it's in that simplified form, you would have to either put it in this form, which is something you'll do in later math classes, or use the opposite of b over 2a, all of that stuff for finding vertex and other points. Okay? So next example, we have f of x equals the opposite of x squared plus 7. So if I'm wanting to try to graph by transformations, I'm looking at this function. So again, let's cross this out. We are going to graph using transformations. Okay. And so since this is a quadratic function, we would start with the basic quadratic. And again, we can only graph using transformations if we can get our function into the form f of x equals a times the quantity x minus h squared plus k. And because there's no x term, that's really easy for us to do in this case, because this x squared, you know, really, x by itself, x minus 0, they are the same thing, right? So this is equivalent to this. And sometimes for some people, it's necessary to kind of see it in this form so that they know which transformations they need to do. Okay, so when graphing with transformations, I first say, okay, if a is negative, I'm going to flip my function over the x-axis. A is negative in this case, so in this case, we will flip. Okay? If necessary, I'm going to move the function to the left or to the right. So that is determined by the number that's here. So minus 0 or plus 0, either would be the same. We're moving left or right 0. So in this case, we are not moving left or right. And then finally, if we have a value here, we're going to move up or down. In this case, we do have a 7, so we're going to move every point up 7. Okay? So what we do, remember, we start with our basic quadratic. So points on this basic quadratic, you need to know -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay? So starting with those points, okay, so if we take this function and we flip it over the x-axis, maybe it's easier to just do that step first. So if we take this function and we flip it over the x-axis, this point is going to be at -2, -4. Is that 4? 1, 2, 3, 4. -1, -1. This will be here, and this will be here, right? And then we're not going to move those points left or to the right, but we are going to then shift up 7. So right now I have this downward facing parabola, which I expected from what I remember from the last chapter. If A is negative, my parabola should open down. So I'm going to now take these points and move all of them up 7. Okay, so up 1, 2, 3, 4, 5, 6, 7. This one, so that's gone. Up 1, 2, 3, 4, 5, 6, 7. Gone. This is up 1, 2, 3, 4, 5, 6. I must have messed up. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There we go. That's gone. And then move that up 7. And then I'm going to move this up 7. And this is going to now be the graph of this parabola. And if ever you are unsure if you really did your transformations correct, check your points. Okay, and I have a point at -2, 3. Right, the points that I now have, I've got a point at -2, 3. I have a point at -1, 6. At 0, 7. At 1, 6. And at 2, 3. Sorry, I kind of ran out of room. Is it true that if you substitute -2 in for x, that the corresponding output is 3? So we have the opposite of x squared plus 7. So if we do -2 times -2, that's 4. And -4 plus 7, I do get 3. If I substitute -1 in for x, -1 times -1 is 1. Opposite of 1 is -1 plus 7 is 6. And so we see, if we continue on, it is true that these are ordered pairs that satisfy, or those are input-output pairs for the given function. So if you aren't feeling very confident in your transformations, please do check the algebra on the order pairs that you have found. Okay? Another thing that we can do when we're working with quadratic functions is look for a maximum or a minimum function value. So anytime you are asked to find the maximum or minimum value of the function, it's implied that you're looking for the maximum or minimum y value. And that's going to be important, you know, as you're going through this. So when we're talking function value, that's talking what y value, because if you're looking for the value of the function value, you're looking for the output when the output is the y value. Okay? When we're dealing with parabolas, we can either have parabolas that open up or we can have parabolas that open down. Okay? And if our parabola opens up, again, I'm going to put my arrows on, so it goes up forever. And this one goes down forever. So if you're looking for the maximum y value, you're looking for, does this have a highest y value? Does this have a minimum? Does it have a lowest y value? So if I'm looking at this function here, I see that, you know, this, for this x value, I have a corresponding y value of 7. As x gets larger, the value of y keeps getting bigger and bigger and bigger and bigger. And so my question is, do I have a highest y or do I have a lowest y? And so when you look at this, it just keeps going up forever and ever and ever and ever. It keeps going out, but it goes up forever and ever. So because we don't have a highest point, we can't have a maximum y value. There is no highest y value because there's always one higher. There is, however, a lowest y value because there is a lowest point, and we call that the minimum. So if you're dealing with a parabola that opens up, it has a minimum value. And that minimum value, it is the minimum y value. So the lowest y value here is 3. So we say that the minimum function value is 3. When we look at this parabola, I'm trying to decide first, do I have a maximum or do I have a minimum? Do I have a highest point? Do I have a lowest point? Okay, this parabola is going down, and it keeps going down forever and ever and ever, meaning it does not have a lowest point. It does, however, have a highest point, and the y-coordinate of that highest point is 2. That highest point and that lowest point, please note, happens at the vertex. Okay, so this function does not have a minimum, but it does have a maximum of 2. It does have a maximum y value equal to 2. Okay, so if we go on with that, determine whether the given quadratic function has a maximum or minimum value, then find that maximum or minimum. So when I look at this quadratic function, I know that every quadratic function, the graph is a parabola. I also know that if the value of a is positive, since a is greater than 0, I know that the parabola will open up. So this function is going to look something like this. So the question is, does this function have a maximum value or does this function have a minimum value? Right? Does it have a highest point? Does it have a lowest point? To have a maximum value, it must have a highest point. To have a minimum value, it must have a lowest. This goes up forever. It does not have a highest point. It does, however, have a lowest point. So this will have a minimum function value. And the minimum function value is, this minimum value is going to be the y-coordinate of this lowest point, which in the world of parabolas is called the vertex. Okay? So to find the minimum function value, we're going to have to find the y-coordinate of the vertex. And if you go back to what you know, if you're given the equation in this simplified form, then the x-coordinate of the vertex is found using the formula opposite of b over 2a. So in this case, a is 1 and b is negative 7. So the opposite of b is positive 7 over 2 times 1, so that value is 7/2. And from what we learned before, once we know the x-coordinate of the vertex, we can substitute that into our function to find the corresponding y value. So f of 7/2 is going to be 7/2 squared minus 7 times 7/2 plus 13. And I strongly encourage you to just type that into your calculator so that you don't make calculation errors. Okay, so we have, if you can see, 7 over 2 quantity squared minus 7 times 7 over 2, and watch your parentheses, plus 13. No, I can't see that. That says 3/4. Okay, so f of 7/2, or for an x value of 7/2, the corresponding y value is 3/4. So 3/4 is the y coordinate of this vertex, which is the minimum value of the function. So the minimum function value is 3/4. Okay? Determine whether this quadratic function has a maximum or minimum value, and then find what it is. So looking at this, since a is less than 0, since a is a negative number, I know that the parabola opens down. Okay? So the parabola is going to look something like this. So when I look at this parabola, it does have a highest point, it does not have a lowest point. So this will have a maximum value, and again, the maximum value, it's always y value. So this is going to be the y coordinate of our vertex. Okay, so again, we're going to have to be able to find the y coordinate when it's in this form, we have to start by finding the x. So the x coordinate is the opposite of b over 2a, which is -5 over 2 times -1. -5 over -2 is positive 5/2. Once we have the x coordinate of the vertex, we input that into our function to see what the corresponding output or the corresponding y value will be. So our f of 5/2, we have the opposite of 5/2 squared plus 5 times 5/2 minus 38. Again, if you input that into your calculator, so we have the opposite of 5 over 2 squared plus 5 times 5 over 2 minus 38, we get -127 over 4. So the corresponding y value is -127 over 4. So the maximum function value is going to be -127 all over 4, or just over 4. Okay, one more example, and then we'll do a second video here. Determine whether this given quadratic has a maximum or minimum value, and then find what that is. So here we were given a different form, and this one again is much easier to work with. Still, to decide if it opens up or down, we have to look at the value of a. In this case, a is 1, right? So a is a positive number, which means that my parabola is going to open up. So it's going to look something like this. And so now I know that I'm going to have a minimum value, and that minimum function value is going to be the y coordinate of the vertex. And if you think back to what we were doing in the last chapter, if you're given the function in this form, then the number that makes inside of here equals 0, that's the x coordinate of the vertex, and this number here is always going to be the y coordinate of the vertex. So there's really no work to do in this case, because the y coordinate of the vertex is 108. So our minimum function value is at y equals 108. Let me know if you have any questions.